All right, in this video we're going to talk about ellipses. We're going to talk about some of the basic characteristics of them and then go through a couple of examples and just really talk through how to find all the information that we would need to answer questions. The SOL for today is MA6, which says that you, the student, will investigate, graph, and identify the properties of conic sections from equations in vertex and standard form. As we get started, quick shout out to Sanaya, who I know is going to be watching this today. So let's talk about these ellipse basics, the things that you need to know. This is really the foundation for how we get started, but it's important to connect it to the image that we're looking at. So in the OMHS, they specifically describe a horizontal ellipse and a vertical ellipse. The main difference is where you notice the A's and the B's are placed in the denominator, and it's important to know that A is always the bigger number. So we have a horizontal ellipse, meaning that the longer side is horizontal when the A value, when the bigger number is under X. And then we have a vertical ellipse, meaning that the longer side is vertical. That is when the A value is under the Y. So that's how you're going to differentiate between a horizontal ellipse and a vertical ellipse. It's based on which number is larger. You'll notice that the equation of an ellipse always is equal to 1. So check for that before you begin any work when dealing with an equation. Some characteristics here that we see, we have what's called the major axis of an ellipse, and that represents the long line here that goes through the center. So it goes through the long side. We then have the minor axis, which goes through the shorter side. Same thing on the vertical, they're just in opposite directions. So the major axis is the long side here, and then the minor axis is the small side. The center point can be moved around for an ellipse, and so you'll notice that the center point in an equation is found up here with the x's and y's. We've been really familiar with this, so this should be something that you can do, that you're comfortable with. And then we have what are called focus points. So these focus points here are a distance that we're going to call C, so C distance from the center, and they always lie on the major axis. Okay, the focus points, we're going to talk a little bit how to apply those transformations, but those are related to your center point. If it's a horizontal ellipse, then you add that distance C to the x coordinate. You add or subtract it. And if it's a vertical ellipse, you add or subtract that distance C to the y coordinate. Okay, and then we have what's called a focal radius, and that is the length from the center to the focus. That's our C value. The important relationship here between all of this information that we need to know looks like Pythagorean theorem, but it is important to notice that this right here is in a different order than you originally learned Pythagorean theorem, and that is important. Okay, what we see here is a squared, which this is the value that is related to the major axis, right? The major axis is equal to 2a, so that's the a value. It's the same a value that we see in the denominator of our equations. The b value here, this is the number that's related to the minor axis. Okay, again, the minor axis is equal to 2b, and you'll see that that is in the denominator of our equations. And then the c value here, this is the focal radius, okay, related to the focal radius. And again, that has to do with where those focus points are, but this relationship is going to help us find that information when it's missing. So let's take a look at an example. We're going to identify all of these things so that you know anytime you see an equation, you're going to have the ability to find any one of these points regardless of what the question might be asking you. So starting with the center point, we know that the center point, actually first starting with whether or not this is a horizontal or a vertical ellipse. So looking at the equation here, we look to identify where the larger number is. We see that that occurs under the x. So that means that this one here is a horizontal ellipse because the larger number is under the x value. The center point is based on the numbers that are in here with the x and the y. Remember that it's always going to be the opposite of what you see. So the center point for this ellipse is at 4, -2. Next thing I can identify is the major axis. Okay, we know that the major axis is equal to 2a, and we know from our equation that a squared is equal to 36. If a squared is equal to 36, I can take the square root of both sides, and I know that a is equal to 6, which means that the major axis, which is 2a, is going to be equal to 12. We use a similar process for the minor axis, but the minor axis is equal to 2b. From my equation, I know that b squared is equal to 16, and so I take the square root of both of those to come up with b is equal to 4, which means that my minor axis is equal to 8. Now the vertices on an ellipse, okay, those are the points here that intersect with the major and the minor axes. And so those are a consistent distance between the center out to the vertex, right? It's from the center to the vertex is half of the major axis on the major axis side, and then the other vertices go from the center to the minor axis, so it's the distance of half of the minor axis. So for my vertices on the horizontal side, right, the major axis side, I know that it's a distance of 6 units. And so that is going to mean that I subtract 6 from the x-axis, and then I add 6 from the x value, not axis, sorry about that. So that gives me a vertex of -2, -2, and a vertex of 10, -2. I apply a similar process for the minor axis, except my distance for the minor axis is 4, right? Half of the minor axis. And so I'm going to add and subtract that to the y value. So I have 4, -2 minus 4, and then I have 4, -2 plus 4. And so the vertices on the minor axis side are going to be 4, -6, and 4, 2. Keep in mind that this right here is telling me points that are going to be on the graph to be able to sketch that ellipse. Okay. The next thing here is the focal radius. Remember that the focal radius is equal to c. And so in order to find the focal radius, I use the relationship that almost looks like the Pythagorean theorem, but not quite. And that relationship is that a squared is equal to b squared plus c squared. Okay, remember that a squared and b squared we're going to be able to find directly from our equation. So we know that a squared is 36, we know that b squared is 16, and we know that we're solving for c. I subtract 16 from both sides, which gives me 20, and then I take the square root of both sides, and when I simplify that radical there, I end up with 2 square root of 5 for the distance, for the length of my focal radius. That helps me find my focus points. Remember that the focus points are always going to lie on the major axis, and so the focus points, in this case, since we're dealing with a horizontal ellipse, are going to be added and subtracted from the x value. So this is going to be 4 plus or minus 2 square root of 5, -2 will be the 2 points for the focus points. One of them will be adding and the other one's subtracting. The last thing I want to talk about is eccentricity. This right here tells us how close an ellipse is to being a circle, and it's equal to the ratio between C and A. The closer that ratio is to 0, the closer the ellipse is to being a circle. So if I wanted to identify the eccentricity of this parabola, I would take my C value, which is 2 square root of 5, and I would divide it by my A value. And remember that my A value is equal to 6. I can reduce that fraction there, and I end up with the square root of 5 over 3. With all of that information, we would be able to answer any question about this particular ellipse. I want to talk now about how to do this if we're not given an equation, but we're given pieces of information. So in this case, we know the focus points, those are given to us. Those are at the point 3, 1 and 7, 1. And we know that the major axis, which is equal to 2a, has a length of 10. So looking at this, think for a moment, is this a horizontal or a vertical ellipse? Since the x x values is where we see the change in the focus points, right? That's where the focus points are moving. Then that would make this a horizontal ellipse. My focus points are on the x line, right, on a horizontal line, and so that's how I know that it's a horizontal axis. In order to find the center point, since I know the two foci, I hate that word, by the way, I know that the center point exists right in the middle of those two. So finding a midpoint means that I add the points together and divide by 2. So I have 3 plus 7 divided by 2, and then I have 1 plus 1 divided by 2. So my center point is at 10 divided by 2, which is 5, and 2 divided by 2, which is 1. So the center point again is found by finding the midpoint between the two focus points, and midpoint is found by adding the two values together and then dividing by 2. The major axis is information that's already given to us, but it is important to know that this also tells us our A value. Since the major axis is equal to 2A, and the major axis is a length of 10, I know that my A value is equal to 5. The minor axis is something I don't know yet, but remember that the minor axis is equal to 2b, and so I would find the minor axis once I know my b value. I can find my b value if I know a and c, right? Because we have that important relationship that a squared is equal to b squared plus c squared. Our c value comes from the focal radii, and the focal radii are going to be the distance from the center point to the focus points. So finding distance between those means that I subtract their value, right? The change is happening in the x's, and so I can see that it goes from 3 to 5 and from 5 to 7. So my c value is equal to 2, and so that is my focal radii, or radius. Since I now know my a value and my c value, I can solve for b. So I'm going to plug in 5 for a, I'm going to plug in 2 for c, and I'm going to solve for b. So I have 25 is equal to b squared plus 4. So I subtract 4 from both sides, and b squared is equal to 21. I take the square root of both sides, so b is equal to the square root of 21. That means that my minor axis, which is equal to 2 times b, is going to be equal to 2 times the square root of 21. My vertices then, remember, we're adding from the center point. So on the major axis, which has distance of 5, I take my center point. It's a horizontal, so my major axis is the change in the horizontal. I take my center point and I add and subtract 5. So I have 5 minus 5, and then 5 plus 5, and 1. So the vertices there are going to be 0, 1, and 10, 1. And then for the minor axis side, this is an ugly number here, but we're changing the y values, and so it's going to be 5, and then 1 plus or minus the square root of 21. Then for eccentricity for this one, again, that's the ratio of c to a. The closer it is to 0, the closer the ellipse is to a circle. And so my c value here is 2, and my a value is 5. And so the eccentricity for this ellipse would be 2/5. And the last thing I want to talk about is just writing that equation with all this information. So I know that I have x minus 5 because my center point is at 5, 1. Since it's a horizontal ellipse, a squared is what goes on the bottom, so that's 25 on the bottom. And then I have y minus 1, again that's 1 from the center point, and underneath the y is going to be b squared. Well, remember that b is equal to the square root of 21, so b squared is equal to 21, and that would be equal to 1. So with all of that information, you would be able to answer any question about this ellipse. So walk yourself through all of these pieces of information anytime you're working with an ellipse. It's like a puzzle that you're filling in back and forth, really relying heavily on the relationship between A, B, and C.